Welcome to this lesson. In this particular course, you're going to learn about data analytics with R programming or R programming for data analytics. That's the aim of this particular course. To start with, we are going to start with the introduction to data analytics, and then in the coming parts of the lesson and modules, you'll get to understand the in-depths on how you can use R programming for different purposes in your data journey. So first, we'll be able to understand what data analytics is, because what usually changes is actually the tools we use in torturing the data. However, the data analytics process usually has the same objectives. So we'll explore what data analytics means in this particular session, why it matters, and how to transform raw data into meaningful insights. We are also going to learn about 4 key types of analytics, which is descriptive statistics, descriptive analytics, diagnostic, predictive, and prescriptive analytics, and their real-world application. And so from there, in the coming session, we learn about the role of R programming in this perspective, and also the R's environment setup for you to now be in a position of being able now to run successful R programs with your data. The objective of this particular session is to help you understand what data analytics is, identify the analytic types, understand the data importance, and also the real-world application of this. What is data? Data refers to raw facts, figures, observations, or measurement collected from a real world. So on its own, data has no meaning. So it becomes useful only when it's organized, is processed, is analyzed. Data can be numbers, data can be text, data can be images, can be sound, any recorded information. All this provides useful information. Example, like let's say a school record can have student name, student age, student scores. Hospital records can have patient symptoms, test results. All these are forms of data. Even the x-rays, the scans, all those are sources of, all those are from what we call data. So definition of data, these are raw facts, figures, observations. This can be numbers, text, symbols, as we've already seen. Some sample data, as you can see from this table. This is structured data, where you can see it's organized in a table. So you can see you have name, age, salary. This is the most common, where data is organized into rows and columns. We call it structured data. However, in most cases, data will not always come in that particular format. Now, what is data analytics? Which is what we'll be going to learn in this particular program. Data analytics is the process of collecting, cleaning, transforming, and analyzing data to uncover meaningful insights that support better decision making. What are the key components of the data analytics? Data analytics actually has like 5 steps. However, the key components are data collection, which refers to now gathering raw data from various sources, data cleaning, where we are now looking at how we can remove errors, duplicates, and missing values. Then we have data transformation, where we can restructuring and structuring the data for better analysis. And then now we have data analysis, which now refers to exploring patterns and relationships from the data. The sole purpose of data analytics is to turn raw data into actionable insights that drives smarter decision across businesses, healthcare, agriculture, education, and many more. Data analytics helps turn raw data into meaningful insights. Some of the day-to-day examples or application of data analytics in real world. For instance, consider retail businesses where you go and purchase whatever you purchase is being recorded, when you purchased, which product did you purchase, how much did you purchase it, what was its expiry date, and so on. There's a lot. The price of each unit, how many did you purchase, so that they can have informed decision. And it goes beyond that. It goes to healthcare. It goes to inventory, to warehouses. It goes to different areas, even agriculture, even social media. So it's very wide. For supermarket, this is now for sale. So supermarkets collect enormous amount of data every day from checkout transactions that we do, loyalty card usage, every purchase is recorded and analyzed. Data analytics help actually the supermarkets to understand customer behavior and also manage inventories, which can in return maximize the revenue, turning everyday sales into a powerful business decision. So what data is tracked in these areas? These are things like the products sold daily, the revenue per product category, customer purchases. All this data is very, very informative. Some key analytical questions that we usually need to understand is they include like which product sells the most, which month has the highest revenue, and actually what could contribute to that. That's a case study for the supermarket. For social media platforms, generating massive amount of data every seconds. For example, how many people use Facebook, Instagram, TikTok? How many posts do we have in every second, every minute? You can see all that data. So all these platforms collect, analyze user interactions to understand behavior, and they also improve engagement so that you can be personalized content. You can get personalized content to billions of users worldwide. Is very, very important in healthcare. Healthcare organizations generate vast amount of data every day from patient records and lab results to hospital administrations and treatment outcomes. Actually, data analytics help transform this raw information into life-saving insights, enabling healthcare providers to deliver better career, better care actually, and allocate resources efficiently and respond proactively to public health challenges. And so data help in decision making, also try to be able to like 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 be able to handle some outbreaks efficiently, be able to monitor the patient recovery, and be able to also work on the outcomes also over time to check on some kind of disease. So from there now we move to the part where we can be able now to dive deeper into the data analytics process in details. So the data analytics process, it has, as I said, had 5 steps. So we'll see. So data analytics follows structured 5 steps: data collection, data cleaning, data analytics, data visualization, and decision making of from the data. Each step builds on the previous. Where you get raw data, you collect the data, maybe from mobile apps, from sensors, from databases, from website. All this data is collected. Collecting relevant and quality data is the foundation of any successful data analytics project. The aim of data analytics is to aid in decision making. That's why you see in step 5, we have decision making. So data cleaning is usually takes actually 80% of the data analysts and data scientists, because this data, when you get data, it can't always be ready for use. You will need to clean the data, remove missing values, handle duplicates, handle outliers, handle any errors from the data, ensure that the data is accurate, is reliable throughout the entire analytics process. That's the very critical stage. Remember, garbage in, garbage out. We need to rely on this data for decision making at home. So data analysis now comes in to help us explore the data, to uncover patterns from the data, looking at the trends, looking at the relationships. And examples are things like performing averages, performing customer behavior trends, revenue growth over time, and so on. So we have seen data can come from different sources, from surveys, from questionnaires, from databases, from mobile applications, from social media, all those. And then our data cleaning, looking at the correct formats, fixing inconsistency. Data analytics now, where we perform the calculations, where we do some statistical methods. Like for instance, in this particular course, you'll get an opportunity to work with R package, which is a very useful tool in this regard. And then now we have data visualization, where you need now step 4. It's the process of presenting data and analytical findings through visual format, such as charts, graphs, maps, and interactive dashboards. Also part of business intelligence. So instead of reading raw data of numbers, so visual allow us to quickly identify patterns and trends and outcome and of course figure out where there's outliers in the data so that we can handle them. Some of the common visualization tools, visualization charts include bar charts, the column charts, line graphs, the area charts, the pie chart, the donut chart, scatter plot, heat map, and dashboards. Tools that we use solemnly in this area is Power BI business intelligence tool. Tableau is a business intelligence tool. However, in R, we have a package called ggplot2, which we use for data visualization, which you'll get an opportunity to interact with in this particular course. Now, Excel is also there, very useful. You can also start always with the Excel, try to visualize this data, build dashboards with Excel, and build. So why does this matter? Effective data visualization makes complex data easier to understand for all audiences, from analysts to business executives. The key benefit is to communicate insights clearly and quickly. This will support faster decision and better decision making, where everyone can be able to understand the outcomes we get. So in this R programming, we'll get an opportunity to work with ggplot2 package, which is one of the most powerful and widely used tools for creating professional and publication quality data visualization. Now, the step 5 is data-driven decision making. Sole aim of us working with data is basically to drive decision making. Imagine having data in warehouses, having materials in warehouses, cement, sand, without getting those to the field, to the construction sites. All those is useless. There is where now the aim of now data visualizations comes in, driving decision making, improve accuracy in decision making, reducing risks and uncertainties, and also remove or like respond quickly to challenges, allocate resources effectively, and also measure outcomes and adjust where possible. Now, this is a summary of the process. We start with data collection, we go to data cleaning, we go to data analytics, then we go to data visualization, and then we drive decision making. So we have seen that about the 5 steps of data analytics process. However, there are different types of data analytics. We have descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. Let's quickly look at all these and we'll be able to see how they differ. Okay, so descriptive statistics help us answer the question, what happened? This summarizes historical data to understand the past performance. For example, a company sold 10,000 products last month. So we can use reports, dashboards, and summaries to communicate on what happened. Can see. Then we go to diagnostic analytics, which now tells us why did it happen. So this explores causes behind post outcomes. So to help us know, sales increased due to a market campaign, or maybe due to this and due to that, and also help us identify patterns and also help us to be able to know how best we can be able to work with our analytics. And then now we have predictive analytics, which is what is likely to happen. So it becomes useful in this area. So predictive analytics uses historical data to forecast future trends. For instance, you can be able to predict the next month's sales using past data, and you can imagine tools like Microsoft Excel have forecast sheets. We have what if analysis, where you can be able to quickly do these predictions. And then now we have prescriptive analytics, which help us to know what should we do now. This recommends actions that need to be taken based on the prediction outcomes that we have performed. An example is like suggest-based marketing strategies to maximize revenue and most advanced types of analytics. So I think that is enough walk through onto these different scenarios and how they can help us in decision making. So why does data analytics matter? Is a useful tool that can help us transform or empower organizations decision making, make smarter decisions, optimize processes, optimize performance, stay ahead in the competitive landscape. As we usually say, data is a competitive advantage of a particular organization, but with data alone is not enough. You need to transform that data into useful insights so that you can be able to improve decision making, increase revenue, reduce the costs, and also understand the customers, gain competitive advantage from businesses, from finance, from healthcare, education, sports, performance, agriculture, governance, and so on and so on. Career opportunities in data, you can become a data analyst, you can become a data scientist, and you can become a business analyst, or we call the BI analyst, business intelligence analyst. So most tools that we use in this area: Excel, SQL, R programming, Python, Power BI, Tableau. All these tools, you can get resources to these tools in our website, academy.beyonddataict.com, where you can be able to now enroll into Microsoft Excel courses, SQL courses. If you need Python, this particular program will be covering R. If you need Python, you can get resources there. Power BI, Tableau, all those resources are there on our academy.beyonddataict.com. And thank you for this session. See you in the next session. We'll be uncovering how to work with R programming and why it actually matters before we do any installations with it. Thank you.